I'm going to move on to power functions of a new form. Okay, so just now in 1C, I kind of tested you a very simple one, which is a power function where your power function is something squared. So when it's something squared, you can easily expand it and you can actually just integrate term by term. But what happens if your power function has a power of 11? Are you going to expand it 11 times? Not really, right? Okay, so we're going to apply something we've learned in differentiation first, and we're going to reverse this method. Okay, so when we differentiate 3x plus 2 to the power 11, we can apply chain rule, which is we bring down the power 11, differentiate 3x plus 2, which is, that's why there's a 3 there, and then the original function, leave it there, and you have a power of 11 minus 1, which gives you 10. Okay, that is chain rule for you. Okay, now, so we know that integration and differentiation are reverse processes. So technically, right, if I integrate this guy, I should get this guy, right? So this is what I'm going to write here. Integration of the result here must give me this guy plus c lah. The c is just put there for fun one lah. Okay, remember, in indefinite integral, you must always put the plus c. Now, let's apply one of the laws of integration, which is I can bring out the constants, right? I can bring out the constants 11 and 3, correct? So I bring it out. Now I'm going to treat this integration like equation like that. So this means I want to get rid of 11 times 3 on the left hand side. I want it to be able to look like this. And how do I do that?
Divided by 33.
Yeah, I divide by 33, which is just something like that. Sure, doesn't make sense You divide 11, you divide by 33 on... Shouldn't your C also divide by 33?
We don't care.
But we don't really care. Okay, just leave it as C. I say again, we don't really care whether C divide by... Think about it, C is already unknown constant, arbitrary constant. You divide by 33, what does it matter? Is it still an unknown? It's still an unknown, so we don't really care. Okay, eventually then we find. So, let's look at this now. If I integrate a power function, do you see that you actually keep the function here? Right? Your power increases by 1. It's the opposite of differentiation again. Then, instead of multiplying, you divide. What do you divide by? You divide by the new power and the differentiation of 3x plus 2, which is 3. Okay? Can you see the link here? Okay, something similar. So this means if I have a general power here, okay, ax plus b to the power n, I integrate that. Okay, I will have ax plus b to the power of n plus 1 divided by n plus 1 times a. A is the coefficient of the linear term x. Why? How do I get a? You actually differentiate ax plus b lah. Okay, the idea is to differentiate ax plus b. Okay, you differentiate ax plus b, you will get a. Okay, now one of the things you notice is that you will realize that there is a condition that says that n cannot be equal to... sorry, I write wrong. Can you all change this here? No. Can you change to -1? N cannot be equal to -1. Can you all change it here for me? Okay, I typed wrong. I typed it wrong. Okay, why can it not be -1? Because your denominator will be equal to 0, right? So we cannot have this condition where n is equal to -1. Okay, so this means that at the top I might have made the same mistake. Let me see. Sorry. Okay, so can you all go back to this page also, page 1. I made a mistake here also. Can you all cancel out the n not equals to 1? It's supposed to be n not equals to -1. Okay? Go to page 1 also. Page 1 should be n not equals to -1. Okay, I made a typo there. All must take note, n cannot be equals to -1 because your denominator will become 0. Right? But we will come to that. What happens if n equals to -1? Okay, we'll come to that later. So going back here, very simply, I'm going to just roughly show you how quickly this can be done. If you have a power function now, you want to integrate the power function. Okay, you have to write it like that. How to integrate this? Simply keep the function, so you have 2x plus 7. But your power now is 6 plus 1, so it gives you 7. Divided by the power that you just increased, which is 7, times 2. You differentiate 2x plus 7. Okay, plus c. Okay, of course you need to simplify the number lah. Okay, so you will get 2x plus 7 to the power of 7 divided by 14 plus c. That's all. Okay, next, if you have a surd form, as I said, all surd form, you can express it in index form. So this index form will be negative half. Okay, so what you're trying to do now is integrate 3 times of 5x plus 4 to the power of negative half dx. Remember, the constant can leave it out. Okay, of course, you can simply just write 3 times of 5x plus 4 to the power of what? What is negative half plus 1? Positive half. Okay, what is it divided by? By half times 5 plus c. Okay, so what I want you to take note here is what I'm doing here is using the formula, the new ax plus b to the power of n plus 1 divided by n plus 1 times a plus c. Okay, so I want you to be able to see this connection here. Now from here, you have to make your simplification. You don't know how to do it, you must know how to do it. Okay, this is simply 6 over 5 times square root of 5x plus 4 plus c. Okay, it becomes positive power already. Okay, now so you must ask yourself, how to check integration, whether your answer correct or not?
Differentiate.
Yeah, correct. You differentiate. You differentiate your final answer, see whether you get back the original function that is given to you. Okay, simple? Yeah, fairly straightforward. Not too difficult. Alright, so that's it for the simple power functions.